Any questions over any of the assignments we've done thus far? Or anything we've... Also, if you have any of your assignments for Chapter 7, the last chapter, they need to be turned in by the end of the day today. Otherwise, they are zeros. Otherwise, they will be zeros. All right. Now, what we're looking at today are dealing with a lot of the properties of exponential or exponents. And we do have several main properties here. And you've worked with these before, you've done these before. Our product of powers, if we multiply like bases, we add the exponent. Okay. And then our power of a power, whenever we have an exponent or number, variable to a power, we multiply the exponents, our power of a power property. Now our power of a product would be our a times b to the n, where we have something being multiplied, two things being multiplied together to an exponent. We actually apply that exponent to both. Our negative exponents, a to the negative m is going to be equal to 1 over a to the m. To make exponents positive, we either move it from the denominator to the numerator or numerator to denominator. Because going in either direction will change the exponent from positive to negative or negative to positive. Our zero exponent, well, anything to the zero power is 1. Anything to the zero power is going to be 1, and that works for everything except, well, 0. Quotient of a power, quotient of powers. And our quotient of powers is talking about if we have two like bases being divided by each other, we would subtract the exponents. And then our last one, power of a quotient. If we have a divided by b to the n, well, we can say a to the n divided by b to the n. And these here are main properties dealing with exponents. And we could use it going from one way to the other, going back and forth. Because depending on what we have, utilizing these here, utilizing each one of these here, is really going to help us being able to simplify these radicals in any way, shape, and form. Now, to know that we have it in simplest form, we have three main things that we're going to need for it to be. And the first one is no radicals can have perfect nth powers factors other than 1. That means we can't leave it as the square root of 4. We cannot leave it as the square root of 4 because the square root of 4 can reduce. It can simplify. Or we can't have 3 to the 3/3, or we can't have 2 to the 6/3. We can't have these that can reduce, because if they can reduce, we need to simplify them. We need to remove the radical out. And the second one is no radicals can contain fractions. I cannot have the 5th root of 3/4. We cannot have a radical, a fraction inside these radicals. And the last one, we can't have a radical appear in the denominator. I can't have a square root, cubed root in the bottom of a fraction. We can't have radicals in the bottom of a fraction. We can't have fractions inside of a radical. And if we can reduce them, we need to reduce them. and it's not included here, but we can't have negative exponents. Because if an exponent's negative, we do need to make it positive by moving it either to the numerator or to the denominator. Any questions on this so far? Okay, so let's actually look at some of these here with simplifying and using these properties. Now the first one that we have is 7 to the 1/4 times 7 to the 1/2, and we want to simplify these as far as possible. Now here, since we have like bases being multiplied together, means we will add the exponents. When we multiply like bases, we add the exponents. So here we're going to have 7 to the 1/4 plus 1/2. Now to really finish simplifying it, we need to add 1/4 plus 1/2. Well, we can do this by hand or in the calculator because either one will work. Because when we add 1/4 plus 1/2, we need the bases to be the same. So we would multiply the 1/2 by 2 over 2, which would give us 2/4. And 1/4 plus 2/4 is 3/4. So that means we would have 7 to the 3/4. Any questions on this here? If there's no questions on that one there, we can look at the next one here. We have 6 to the 1/2 times 4 to the 1/3. Well, 6 and 4 are not like bases, and there's no way we can get them to be like bases. Because the only way that I can get 6 and 4, if it was possible to be like bases, is to rewrite them as a number to a power. Because if I could rewrite 6 as a single number to a power, and 4, which I can, which would be 2 squared, if I can rewrite both of them as 2 to a power, then we couldn't actually multiply them. But 6 and 4, there's no way to get them to both have a base of 2 to a power. So we can't do that multiplication. But our product of a power, or sorry, power of a product, we can multiply both of these by our 2. Because our product of a power is our a times b to the n is our a to the n times b to the n. So really we can say our 6 to the 1/2 times 2 being multiplied with our 4 to the 1/2 or 1/3 times 3, because we can apply that 2 to both. And if we do this multiplication here, well, 6 to the 1/2 times 2 would be 2 over 2 times 4 to the 2/3. Well, 6 is 2 over 2. 2 divided by 2 is 1. So really we have 6 times 4 to the 2/3. And that's as simplified as it gets because we don't have any of these fractional exponents in the denominator. We don't have any radicals in the denominator. We don't have any fractions contained. And those are as simplified as they get. That's as far as we have to go with this here. Any other questions or any questions on any of this here? All right, let's look at the last one on the set of 3. We have 4 to the 5th times 3 to the 5th, all of this to the negative 1/5. Now we could apply the negative property, the negative exponent property now or later, it really doesn't matter. Now if we went on and used our power of a product, we would be multiplying both of these by negative 1/5. So we'd have 4 to the 5th times negative 1/5 times 3 to the 5th times our negative 1/5. fifth. Because again, our product of a power, we're able to apply that exponent to all the terms inside. Now our 5 times negative 1/5 would be negative 5/5 times 3. Our 5 times negative 1/5 would be negative 5/5. Now 4 to the negative 5/5, well, would be just 4 to the negative 1, because a number divided by itself is 1, times 3 to the negative 1. Now we can't leave exponents negative, we have to make them positive. So to make it the exponent positive, we have to move it from the numerator to denominator or denominator to the numerator. Well, the 4 would go from the numerator to the denominator and become really 4 to the first, or we can just write it as 4 times 3 to the first. Because again, 3 to the negative 1, we'd have to move it down to the denominator to make the exponent positive. Well, 4 and 3 are both to the first power. Can we multiply just 4 and 3? And what would we get? 1/12. And that would be it. Any questions on these here? If there are no questions on any of these here, so you want to look at D and E. Now when we look at D, we do have like bases being divided. Whenever we have like bases being divided, we can go on and subtract the numerators. And this is our quotient of a power property. So the exponent in the numerator, since it wasn't given to us, is understood to be 1 minus our 1/3. At this point here, we have to do our 1 minus 1/3, and 1 minus 1/3 is 2/3. And that's as simplified as it gets. We don't have any radicals or fractional exponents in the denominator. All of our roots are as simplified as they get. So this is it here. Any questions on any of this here so far? All right. If there's no questions on anything we've done so far, we'll go on and look at E. E, we have 42 to the 1/3 over 6 to the 1/3 squared. Now looking at this here, can we take the cubed root of 42 or the cubed root of 6? Well, probably not, because I know we can't take the cubed root of 6. There's not a number multiplied by itself 3 times. That does give us 6. But it is interesting that 42 and 6 are both applied to the same power, because that's working off of our power of a quotient, which is our a divided by b to the n is equal to a to the n over b to the n. We can apply the power to both, yes? We can also go the opposite direction and go from this here back to a divided by b to the n, because we can go in either way. And the reason that we might do this is if we looked at this here, 42 divided by 6, will 42 divide by 6 evenly? Well, yeah, because if moving those powers, those 1/3 powers, back to the outside will give us something that we can divide and we can reduce those fractions or get rid of fractions, we would need to do it. It will help us in simplifying this. Because what we can say is that this here is 42 divided by 6 to the 1/3 squared. Because we can use that quotient or power of a quotient to take it from 42 to the 1/3 over 6 to the 1/3 back to 42 over 6 to the 1/3. And well, 42 divided by 6 is 7 to the 1/3 squared. And lastly, to simplify this here, because we don't need all these parentheses, we can go back to our power of a power, because power of a power, the exponents multiply together. Now the 7 is actually to the first. So really we're saying we have 7 to the first times 1/3 times 2. We're just multiplying all those exponents together. Well, 1 times 1/3 is just 1/3. So we're really looking at 1/3 times 2, which is 2/3. So with this one here, because we were able to take 42 divided by 6 and get a number, that's why we wanted to pull those 1/3 away from it so that we could simplify that fraction, making it easier to work with. And a lot of this here is seeing how can we manipulate these numbers so that they're easier to work with and easier to simplify. So we're utilizing these properties to make it easier to simplify these down or simplify them down as far as we possibly can. Any questions on this here? All right. Let's look at the next one. We have 2 to the 3/4 times 2 to the 1/2. What can we do for this here? What would this be? We'd have 2 to the what? Right, we would add them together. So we would be adding the 3/4 plus 1/2. We wouldn't be adding the 2's because when we multiply like bases, we add the exponents. So we'd be doing 3/4 plus 1/2. Unfortunately, at this point here, we can't type the entire thing into the calculator because it's going to try to give it to us as a decimal. It's not going to actually just rewrite it as 2 to an exponent. But can we type 3/4 plus 1/2 into a calculator and get a fractional answer? Well, yeah, the calculator will do that. And this would give us 5/4, because 3/4 plus 1/2 would be 5/4. Any questions on how we got 2 to the 5/4? Let's look at the next one. We have 3 divided by 3 to the 1/4. Well, since we have like bases, we can do what? Subtract the exponents. And the exponent in the numerator is 1 minus 1/4. At this point here, we just need to do 1 minus 1/4, which would give us 3 to the 3/4. And that's as simplified as it gets because we don't have any radicals in the denominator. We don't have anything that we need to simplify. So that is as far as it goes there. Any questions on any of this here? Okay. Let's look at 3 and 4. Now, if we look at number 3, we have 20 to the 1/2 divided by 5 to the 1/2 to the 3rd. Now, we can't take the 20th to the 1/2 or 5 to the 1/2 evenly, because 1/2 is just saying that we're taking the square root. I can't take the square root of 20, and we can't take the square root of 1/2 evenly. There's not a number that multiplies by itself to get 20, and 5 is prime. But what do we notice about 20 and 5? What are they? They're divisible, yes? Because I can do 20 divided by 5. But in order to be able to do that, 20 divided by 5, we have to use our power of a quotient property to rewrite it as 20 divided by 5 to the 1/2 to the third. Now, what is 20 divided by 5? 4. To the 1/2 to the third. Yes? Well, we said 1/2 is the same as what? A square root, yes? Can we take the square root of 4? So really what we're saying here is, again, because 4 to the 1/2 is what we have. 1/2 to the third. And again, our property with roots, a to the nth root of a to the x is equal to a to the x over n. So what this is telling us is that we actually have the square root of 4 to the first. This is one of the ones we can't leave as 4 to the 1/2 because it can reduce, it can simplify. Because the square root of 4 is 2. 4 to the 1/2 is 2. Well, what is 2 cubed? 8. So that would be our final answer. If it didn't work out that it was 4 to the 1/2 did simplify, we could have left it as our 3 times 1/2, 4 to the 3/2. But because it does simplify, there is a perfect nth root in there, we have to pull it out. We have to simplify it down. Questions on this here? Any questions on anything we've done so far before we look at number 4? All right, let's look at number 4. We have 5 to the 1/3 times 7 to the 1/4 to the third. Now for this one here, we can use our power of a product because we have two things being multiplied together to an exponent. So we can multiply both of these exponents by 3 according to this property, which is telling us that we have 5 to the 1/3 times 3 times 7 to the 1/4 times 3, because we can multiply both of those exponents by our 3 according to our power of a product. Now our first one here, 1/3 times 3 is going to be, well, 3/3 times 7 to the 1/4 times 3 is 3/4. Well, 3/3 is just 1. 3 divided by 3 is 1, so we will just have 5 to the first, or we can just rewrite it as 5 times 7 to the 3/4, because 3/4 won't simplify any further, and that's as far as we can take it, because we're not having to rewrite these back as fractional exponents or back in radical form. Because if we wanted to, this would be 5 times the 4th root of 7 cubed, and then we could see what 7 cubed is to see what this would be. But for these here, they're not asking us to rewrite it in radical form. Any questions on any of this here? Do we need to see another example of one of these? All right. If we feel comfortable with this here, because I did include extras, but that is it. And we'll be delving more into this tomorrow as well.